Hi everyone. Today I have come with one of most important video for the student who are following logistic management degree or a diploma. To this video series, I hope to discuss about solution for the transportation problems, and this video will be dedicated for the Northwest Corner method. Especially if you have not subscribed this channel, so you can do it now for the to keep your knowledge updated about logistic field. A transportation problem basically deal with the problem which aims to find the best way to fulfill the demands of n number of demand points using the capabilities of m number of supply points. Transportation is main factor you can consider when you are handling your logistic chain because every phase where you practice your logistic function, you have to take decision regarding the transportation, because it will be one of major factor which is generating cost for your supply chain cost. Because of that, you have to handle that transportation very well, because otherwise the cost for the transportation will be added to a final product, and the market price and your competitive advantage will be lost during your uh, marketing process. Through the diagram, now you can see in the screen, you can understand there can be a number of supply points, m number of supply points, and you can have n number of destinations, which are generating the demands, that's mean requirement. So you have to as a logistician, you have to fulfill the all requirement available at demanding points using the capacities available at your source, that's mean your facilities. So you have to take decision from which supply point you are going to deliver item to the which demand points, that's mean by keeping lowest transportation cost and taking much cost advantage during your transportation process. You have to keep in mind that normally when you are having this type of minimum number of supply points and demand points, you can do it manually. But in today world, you can see multinational companies and very big companies are handling n number of demand destinations, m number of supply destinations, that's mean huge market and the huge source of supplies. So for the for that today world, you can see there are some softwares have been developed to find out this solution, but the basic of these softwares also depend on this uh, methods which we are going to learn today. And through this video I will pay attention especially on Northwest Corner method as a first part of this video series, and definitely you will have uh, number of videos ahead, and I will be discussing about minimal cost method, Vogel approximation method, and how you can find out feasible, that's mean optimized solution using these feasible solutions, and everything will be covered during this video series. As I mentioned before, in transportation problem you can find two phases mainly. One is finding of basic feasible solution, that's mean this it is name itself, it is a basic solution, that's mean you have to optimize this one as a second part of second phase of solving. Definitely before you implement this one, definitely you have to optimize the basic solution which you have find using the method for the basic solution. There you can identify three methods to find out basic feasible solution. One will be a Northwest Corner method, which is we are going to discuss today, and next one is least cost, otherwise minimum cost method, and next one is Vogel approximation method. Okay, let's get understand about Northwest Corner method using example. So through this example, I'm going to teach you how you can find basic feasible solution using the northwest corner method. So you have to keep in mind that during this process we are not consider about the cost factor, so that is why it is called basic one. So just you are going to allocate the number of unit from your source of supply to the your destination, that's my demand destination. In this example you can see there are three uh, demand points A, B, C. That's mean warehouse requirement. The A demand point, that's otherwise warehouse requirement, is 300 unit, B 200 unit, and C 200 unit. And as well as you can see there are three factories known as D, E, and F. And D factory has capacity of 100 units, and E factory has capacity of 300 unit, and F has 300 unit. Especially you have to keep in mind the cost factor which is involved in with the transportation from one place to another place. Even though we are not considering the cost factor in northwest corner method, but you have to get understand about that to continue with this problem solving in future, because in other all formats and other all methods we are considering the cost factor. So here you can see the figures with dollar marks which is denoting the cost which is incurred uh, from one destination to the another destination. As example, from plant D to the destination A, you have to spend $5 for one unit to deliver and arrange transport facilities. And as again from factory D to factory destination B, you have to spend $4. At the same time, it is very much important you have to see whether this is a balanced transportation problem or not. The balanced transportation problem means your demand should be equal to your supply. That's mean here you can see 700 in red color, because the factory capacity is also 700. That's been 100 and 300 and 300, altogether it's 700. And again you can see 300, 200 and 200 in warehouse requirements, and it is also altogether 700. Then we can identify this as a balanced transportation problem. So if you not have balanced transportation problem, prior to you go for the problem solving, definitely you have one step to do to make it as a balanced transportation problem by adding one column or one row. And I will hope to come with such a example in next video. Okay, it is mentioned in the name itself, it is northwest corner method. That's mean we are not considering about the cost factor here, we are just selecting the cell available at northwest corner. Here you can see there are 9 cells with the cost, and you have to find out the most uh, the cell which is located at northwest corner. Here you can see this cell as a northwest corner, and just you have to fill the cell and go ahead and allocating units for the particular cells. The next one which you have to keep in mind is when you are allocating unit for the particular cell, you have to consider the capacities of the factory and the requirement from warehouse or a demanding point. Here you can see warehouse requirement is 300 at warehouse A, but from this cell you have to only supply 100 units because the capacity of factory D is 100. Then you have to allocate 100 units for the cell A and D, that's mean this cell. When you allocate in the maximum amount that you can allocate to the particular cell, then you have to adjust the factory capacity column and the warehouse requirement row as accordingly. That's mean when you are allocating 100 items for the warehouse A from factory D, so you will not able to allocate again unit for any other warehouse from factory D. Because of that, you can cut down and remove the capacity amount from the capacity column as shown on the screen, and after that the factory capacity will be 0 and only that 100 item can be delivered to the warehouse A. And again the warehouse requirement also will be reduced because the warehouse A has received 100 item from factory D, and it will be again come as a 200 units as their balance requirement after fulfilling the requirement from factory D. After that you have to remove the balance part of that particular row because the factory D has no capacities as remaining, because after the fulfilling the uh, requirement as warehouse A, there the full capacity has been given to the warehouse A, and after that factory D will not have ability to deliver items to the any other warehouse. Because of that, you can remove the remaining part of the row particular pertaining to the factory D. Then after that you can see the area which is bounded, which is colored using red color boundaries, and then you have to again select the northwest corner cell using this area, and here you can see the northwest corner cell with $8. That's mean this cell, and you have to allocate items again to the particular that cell as a rule of northwest corner. Here you can allocate 200 item because even though plant E, that's mean factory E, has a capacity of 300 item, but the requirement from the warehouse A is 200 units. Because of that, maximum you can allocate only 200 units for the particular cell. After allocating 200 units for the particular cell, so total requirement will be filled in warehouse A, and the capacity of warehouse E is still remaining with 100 units, and plant E, that's mean factory E, can deliver another 100 items or a unit for the another warehouse. So after that you have to find you can find out the remaining column area of warehouse A, but because you have fulfilled the total requirement of warehouse A, then you can remove and mark it as not considering area for the allocation as shown on the screen. And again you have remaining area which is bounded to using red color boundaries, and that is the area that you have to select the northwest corner because other all area already have allocated. Now you can see the northwest corner cell with $4, and this is this cell. So here you can identify and you can get understand that only 100 items can be delivered from factory E, because though its capacity of capacity is 300 units, but already the 200 unit has been have been allocated to the warehouse A. So only the factory E is remaining with 100 units. So you can allocate that 100 units to the warehouse B because of northwest corner cell. So after allocating that 100 units for the particular cell, so you can see the capacity of factory E has been totally allocated for the warehouse points, that warehouse requirements, that means demand points, and the capacity will be 0. And out of 200 units of requirement of warehouse B, 100 unit have been fulfilled from the factory E, and the remaining requirement will be 100 units again. So here also you can identify, you can see the fully capacity of the factory is uh, distributed among the warehouses. So remaining row will not be able to use for this method because the amount of capacity has become 0. So you have to remove that raw parts for the consideration. And after this we don't have any choice. Definitely you are remaining with 300 requirement at 100 for the warehouse B and 200 for the warehouse C, and you have 300 capacity of supply point F. Then you have to divide this 300 to as 100 for the warehouse B and 200 for the warehouse C. And this will be the allocation for the delivery schedule. And according to northwest corner method, then you have to keep in mind this is a feasible solution. We didn't consider about the cost factor here, just we allocated item for the northwest corner cell, and we distributed the 700 items which are manufacturing or producing at supply points to the 700 requirement at warehouse points, that's mean demand points. So after that we can calculate the total cost as shown in the screen, and this will be the to 4,200 will be the total transportation cost when we are delivering items using this method, this allocation. But again I am going to remind you, this is not a optimized solution, this is a feasible solution. Just you use to allocate your capacities through the among the your demand requirements, that's mean your warehouse requirement points. So after doing finding this feasible solution, definitely you have to go for the optimization using methods. There are some methods to use optimization, and I will hope to come with videos in future. And uh, with that I'm going to conclude this video. So I hope to come soon with the second part of this video series and minimum cost method. And until then, thank you very much, and be touch with us and subscribe this channel for your upgradation.